This is a help screencast for lesson 5-4 from Everyday Math. This looks at missing numbers and digits. This assignment actually comes across a little bit harder than it looks. It takes a little bit of guessing, a little bit of estimation, and a lot of knowing your facts to really do this sheet effectively. So the directions say, complete the number sentences. Fill in the circles using the numbers 3, 4, 6, or 7. Fill in the rectangles using the numbers 47, 62, 74, or 86. Let's look at how we're going to solve the first problem, A. So it says that one of the circle numbers, one of the single digit numbers, times one of those double digit numbers is going to be 329. Now what we could do is we could try out every single number. 3 times 47, 3 times 62, 3 times 74, 3 times 86. But that would take an awful long time. So we could use a couple different strategies to help narrow it down. First strategy that I'd like to show is taking a look at just the digit that's in the ones place. Now take a look at the digit in the ones place of all the two-digit numbers. The reason we're going to do this is because one of the single-digit numbers multiplied by here, whatever our answer to that problem is, what's in the ones digit, will be the same as over here. Let's look at an example. If I did 3 times 47, 3 times 7 is going to be 21. So I know right away that my ones digit number is going to be a 1. So I know right away that I'm not going to be doing 3 times 47. So I'm going to look for an answer that in the ones place, I'll have a 9. So 3 times 7, no, 3 times 6, 3 times 4, 3 times 8, or 6, none of those will result in a 9. In fact, the only one that will, from our example, is the 7 times 7. 7 times 7 is 49. So let's do that problem completely, just to double check our answer. So we have 47 times 7, and we get 49 here. 7 times 4 is 28, plus 1, 2, 3, 4 is 32. So our answer is 329, which is what our answer is over here. So I know that A is going to be 7 times 47. Now let's take a look at letter C. And this same strategy won't work for C. The reason why is our digit in the ones place is a 2, and there's several different options that'll work. 6 times 2 would give us a 12. Let's see, 4 times 3 would give us a 12. So there's a couple different options here, and we don't want to go through every single one. So we're going to use another strategy and kind of combine them together, okay? So for this example, we're going to look at the first two digits. So what two numbers multiplied together will give us 37, or maybe something more close to 37? 37 is a prime number. So we're going to look for something that will give us something close to 37, maybe a 36, and then we carry our 1 over. So the only thing that would give us something like a 36 is we could do a 6 times 6, and that equals 36. So let's see if that fits our other problem too. So I have 6 times 62, and let's do it over here. 62 times 6. And remember that 6 times 62 is the same thing as doing 62 times 6. You can switch those around either way. 6 times 2 is 12. Carry that 1. 6 times 6 is 36, plus 1 more is 37. And there we have it. We have our answer 372 and our answer 372. And let's remember the purpose of this assignment. It's to give us a problem. And in math, a problem is something that we're not really able to think through on our own. Or it's something that we have to be able to think through and we don't know the answer right away. So we can carry on these same strategies for number 2, the bottom of this sheet. And it says, for each problem, fill in the squares using either the digits 4, 6, and 7. Taking a look at A, I have 48, and so I'm going to look at that ones digit in 8. So the ones digit of the answer of these two numbers multiplied by each other has to be an 8. I could do 4 times 6, that's 24, so my ones digit would be a 4. I could do 6 times 7, that would give me 42, so the ones digit would be a 2. I could do 4 times 7, and 4 times 7 is 28. That gives me an 8 in the ones digit. So let's try something like that. I know that one of these numbers is going to be a 7, and one of these numbers is going to be a 4. Now, I don't really know which one's going to be which yet. We're just filling these in for an example here. So the last number would have to be a 6. So let's go ahead and solve this out. 4 times 7 is 28. Carry that 2. 4 times 6 is 24. And then I have 25, 26. 268 is my answer. Boy, that didn't really work out for me. So let's work on it the other way around here. Instead of doing 7 on top and the 4 on the bottom, let me switch those around. And I'll do the 4 up in this box and the 7 on the bottom. And I'll keep my 6 over here. Okay, let's try it this way. 7 times 4 is 28. Carry that 2. 7 times 6 is 42. 43, 44. And there I have it. So it took a little bit of trial and error, but you can think it through. Now, the other way I could have solved this problem was looking at those first 2 digits and think of 2 numbers that are going to give me something that's close to 44. So I know I have a 4, a 6, and a 7 over here. And I could see that 7 times 6 is going to be a 42. And the boxes I know I'd be looking at then would be these 2 boxes. Not the 2 in the ones digits, but one that's in the ones place, and then one that's in a tens place, because I know I have it multiplied by 10 here. So then I would try it out in the same type of way. I may put the 7 down here, the 6 up here, which we know is going to be the right answer. But I could have tried it the other way first. So by looking at different ways of estimating our sums and thinking about what number might be in that ones place after that multiplication problem, we're able to solve these types of problems a little bit more quickly. When it comes to this type of problem, it's not just a factor of guessing and checking. There is a little bit of rhyme and reason to what you're going to check.